In this lesson, I want to talk all about bones, and that's pretty much why I called it Bones, Bones, Bones. Now, I wasn't just being silly with that name. I said bone 3 times because I want to talk about 3 different aspects of bones. That would be edit bones, pose bones, and bendy bones. Now, what am I talking about when I say this? Well, an edit bone is basically a bone that is in edit mode. That's what Blender calls it, an edit bone. And as you've already learnt, that's got to do with its rest position inside the armature. A pose bone is that same bone, we're just in pose mode. So pose mode is where we handle the animation and constraints, and there's a few settings to how it works inside pose mode. And then finally, I want to talk about bendy bones. This is just that same bone, or it could be, but we just have the bendiness turned on, and I'll explain everything you need to know about that. But first, let's look at edit bones. All right, so here I am in edit mode, and in this item tab up here, you can see that this is a duplicate of the transform information that's in our bone tab. We'll go over the tab in a moment. You can see here that we have an XYZ location for both the head and the tail of the bone. We can move these values around and it's going to update in our 3D viewport. And you can also transform the bone inside the 3D view, and these values are going to update. So that is essentially the position of the head and the tail of your bone in 3D space. You can set the length of the bone here too. That's handy if you know it needs to be an exact value. Another way of changing the length would be to scale it in the viewport. I've gone ahead and turned the bone axes on in the data tab. That's going to make it a little bit easier to show the bone roll value here. But you can also use the shortcut with Control R, and that's going to activate that tool for us. So generally when we're rigging, we position the head and the tail of the bone where we want them to be, and then we use this bone roll to sort out the direction of that Z axis. I will go through all the bone tools in a separate video so they're nice and contained in a convenient location. Next, let's look at the radius and the envelope values. You won't see what effect they have unless you switch over to the envelope display mode. So when you change this, the scale of the tail radius changes. That's going to make the area of influence larger around that tail. And that's the same for the head radius. If I change that, it's going to change the area of influence around the head. And the envelope value is going to change the whole size of that entire fall off area. Now, envelope weights are not the best method for deforming your model. You're better off using vertex weights because you have much finer control. You'll learn more about that later. Now, over in the bone tab, you can see that most of that same information was duplicated over in the item tab, except there is one option here to lock your edit bone. This will prevent you from making any unwanted changes, but honestly, this is going to be more trouble than it's worth. You'll end up forgetting that you've turned this on for some bones, and then you'll try and move them, and you'll waste a lot of time trying to figure out why they're not moving. So I don't think you'll need to use it, but it is there in case you need to. Underneath that, we have the bendy bones tab. We're going to look at that later in this video. So we're moving further down and we can see our relations tab. This one's super important. You can see here, this is where we set the parent of the active bone. You can set that parent by clicking in here and choosing the bone that you want. Or if there's a whole list, you can start typing and it will filter down the bones. I can just manually set that bone parent. And now you can see the relationship line that runs from that bone to the parent. With this connected parent option here, this is physically going to make the child connected to the parent. But if you do turn it on by just clicking this one, it's only going to move the head of the bone. And this is going to leave the tail where it is. And most of the time, this is probably not what you want to do. So you might be better off connecting it in the viewport, which I'll show you in just a second. All right, so what is the deal with a connected parent? Well, as I said, the bones are physically connected and they can't be separated from each other. And that doesn't matter if you move the parent or the child, they are stuck together. But as I've already pointed out, both of these bones still have a head and a tail. They're just stuck in the same 3D space and they can't physically be separated from each other. And that's true for pose mode as well. The location is grayed out, so you cannot translate that child. And even with a constraint, a jackhammer, a blowtorch, a carrot on a stick, there's nothing that you can do to separate that connection if the connected parent option is checked on. It's also worth pointing out that you can see a lot of these settings here in pose mode, but you can't actually change them. At first, you'll be scratching your head wondering why you can't change it, but with more experience, you realize that you can see this information here because it stops you from constantly having to jump back and forth between the modes. All right, after that sidebar, let's get back to some other ways of parenting. It's always easier to set up the parenting while you're working in the 3D viewport. First, you select the child or all of the children if you're working on multiple bones at once. But you select the child or the children first, and then you select the parent last. And then you use the shortcut Control P. Now, there's always a silly little saying that I use in my head when I'm setting up the parenting. I select the bone that I want to parent. I say, "Who's your daddy?" And then I select the parent. I say, "I am." It's silly, I know, but it works. I've never, ever forgotten how to parent. If only it was that easy in real life. Anyway, let's bring up that parenting menu again. You'll see that we have two options. We have keep offset or connected. The keep offset is going to keep your bone in its current position and just set the parenting. Now you can see the relationship line. But if you choose the connected option this way, it's going to move the whole entire bone, not just the head of the bone. So that's the difference when you connect a parent this way. You can disconnect a parent with Alt P, and then you can choose whether you actually want to disconnect the bone. Now this won't actually remove the parenting, it's just going to uncheck that connected option. But if you do choose clear parent, that's going to do exactly what it says on the box. It's the same as clicking this little X to clear the parent in our options over here. We'll go over the next three things a little bit later. That's the local location, inherit rotation, and inherit scale. And also underneath that, we have the bone collections. This is just going to show you what collections this bone is in, but there's actually a better way of managing that, which you'll see in a separate video. And next is our deform options. If you want your bone to deform the mesh, this has to be checked. If it's not checked, no matter what you do, your bone won't be able to deform any mesh. Now this is on by default on every bone that you create, so it's more a matter of turning it off on the bones that you don't want to deform anything. But you'll be going over a lot of that when we do our exercises later. And underneath the viewport display, I just want to point out this little hide option here. If we click this one, it's going to hide that bone. But you also notice that we have that same option in pose mode because they're mode independent. If you hide it in edit mode, it's not going to be hidden in pose mode, and vice versa. A quick way to bring them all back is just by hitting Alt H to essentially undo the hiding. Now you need to do that independently in each mode. And the fastest way to actually hide stuff inside the viewport is just by pressing H to hide, and that will hide what you have selected. And if you want to hide everything except what you have selected, then you can press Shift H. That's all I want to point out for these edit bones at the moment. Let's take a look at pose bones. And over here in our transform information, when we move our bone around, this is the location, rotation, and scale of that bone. But if we jump back into edit mode, you'll see it jumps back to its rest position. So technically, these transformations are animation on your bone. You're moving it away from its rest position. So when we're rigging, we don't need to do any transformations in pose mode, but you will make that mistake when you first begin. You'll be positioning your bones and then you'll be like, oh, I've accidentally moved it in pose mode rather than edit mode. You're going to make this mistake a lot when you first start out, but there is a way to fix this and make this pose the actual rest pose. Up here in the pose menu, you've got apply, and then you can apply the pose as the rest pose. That's going to do the whole character or the whole rig, and this is just going to do the selected bone. This is always a safer option to choose because you may be introducing some unwanted changes with the other option, but with this one, you're confining it to just what you have selected. So I'll choose that one. You'll notice that those transformations have disappeared, and if you jump into edit mode, it's in the same spot. One thing that you might need to change in this transform settings over here though is the rotation mode. By default, this is set to quaternion, which works a lot better for controls that need to rotate on all three axes in world space. However, quaternions are much more difficult for an animator to control. So it's always nice if the rigger can change this for them to choose the best rotation order for their needs. Now, while rotation order is something that's super important, it's pretty complicated. It isn't something you need to fully understand in this fundamentals course. Right now, all you need to know is that these options here are all different rotation orders, and that means the order in which the axes are calculated. A different order could give you a different result and avoid something called gimbal lock. But that stuff's complicated. So what do I recommend at this fundamentals level? If this is going to be a control bone, just change it over to Euler XYZ. This is going to be the easiest option for everybody. It's also going to make the most sense to any animator. I do want to point out where the inverse kinematic settings are for your pose bones. They are inside the bone tab, conveniently under this tab called inverse kinematics, or IK for short. We'll be using these in a later exercise in the course, but I wanted to point out that these settings are specific to the bones. So this bone can have a different setting to another bone. And that's why we don't need to mess with the IK settings at the data level. We can leave that one alone. We want to be using the pose bone settings. That's this one here. All right, here I am inside pose bone, and we're going to talk about this local location option. So I have two bones here. They just have an arbitrary rotation on them. And this one I've called default because I'm going to leave this one at the default setting. But this guy down here, I'm going to turn this one off and show you the difference in behavior between those two. First, the default option. So I'm going to select my bone here. Let's just move our bone on the local Z axis. You can see it's aligning itself and moving up according to the local orientation of our bone. And let's just try the y-axis. You'll see it's moving along the length of the bone. That makes sense. Now here, let's look at the different behavior. If I move it on the z-axis, you'll notice that it's moving straight up, which is different to our skewed angle over here. If I move the y, you'll notice nothing looks like it's happening, but let's just jump into 3D space and you'll see, it's moving along the y-axis in pose space, which is the orientation of our object in 3D space. And if I move our bone on X, it's going to go left and right. So that's what this option does. If we enable it, you'll see it jump in space. It's just changing the way that the local space is calculated or oriented inside the 3D view. All right, let's take a look at this inherit rotation option. Here is just a default chain. So when I rotate its parent, you notice that our bone is inheriting that rotation. But here I'm just going to disable that option and then rotate the parent. And you'll see that it is totally ignoring the rotation. So that's what this one here does. All right, next on our list to talk about is the inherit scale options. We have a few here to choose from. This will kind of show you more about what's going on when we're only scaling on one axis. So I'm just going to scale up my y-axis, which is the length of the bone. Let's just make this 3 so we can kind of see what's going on here. With the default scale settings, that is inherit scale full, you can see how this bone is being sheared. So let's choose a different option like fix shear. And now Blender is calculating that and removing the shearing from that, which is helpful. We can do the aligned. So this is going to transfer that Y scale along to the Y scale on our child. That one's super handy. Now the average is going to average out all of these scales across all of the axes. And then when we choose none, it's going to ignore that scale altogether. We do have another option. We've got none legacy. This is just in here to keep backwards compatibility with old versions of Blender. Perhaps you're working on a really old file. This might be what you need to get that working. But 99% of the time, we can leave this on full. And then occasionally, when we're doing something fancy, I find the best option to use is aligned. And the final thing I want to point out for pose bones is this deform option. This is a duplicate of the setting over in the edit bones. It's just in 2 spots for your convenience. Okay, so that's all for pose bones. Now let's have some fun with some bendy bones. All right, bendy bones are pretty exciting. So here we go. Are you ready to turn this bone into a bendy bone? Awesome. So over here in the bendy bones tab, if we raise this above 1, you'll notice all of our options here are no longer grayed out. So technically, we've made ourselves a bendy bone. Yay! Anything above a segment of 1 is a bendy bone, and we can go all the way up to 32 segments. But you notice nothing is changing in here, and that's because we can't see our bendy bone unless we're in B-bone display mode. So let's change that. Now we can see our bones. So if we slide this down, you can see it's adding or subtracting the segments there. And before I explain all of these settings over here, I want to point out that we have exactly the same settings on our edit bones as we do on our pose bones. So let me just change a few things here and I'll create a curve on our bendy bone. But then when I jump into pose mode, all of those values will jump back to their default settings. So what's going on here? Well, maybe you figured it out from some of the earlier things that I've said, but edit mode is all about the rest position of our bone, or its position before we move things around. And pose mode is all about the animation and the constraints on the bone. So if we add a curve to the edit bone, this means we're adding a curve to the bone in its rest position. But to tell you the truth, I haven't found an advantage of actually having a curve on the edit bone versus keeping it straight and then curving the pose bone. So I'm going to reset all of those changes and then jump over into pose mode to explain things further. All right, so we've got our display size, which you've already seen a little bit before. It doesn't affect the way it functions. It only affects the way that it looks. But I think you'll find using the shortcut is a lot easier, even though it's a very cumbersome shortcut. Control-Shift-Alt-S. Our curve in value is going to be the head of the bone, and the curve out value is going to be the tail. So you can see our x-axis here. If we curve this one, you'll see it curve towards the x. And if we do this one, it should curve towards the Z. Of course, we can go in the negative direction if we want. And this is the same options on the tail of our bone here. The roll in is the twisting at the start of the bone or the bone's head. And the roll out is the twisting at the end of the bone or the tail. And if we enable inherit end roll, that's going to inherit the roll of the end of the bone that it's connected to. Now, at the moment, it's not connected to anything, but if it was, it would take on that roll of whatever the parent was. Now, the scale, this is scaling the B bone along its x-axis, and you notice that it is scaling along that twist as well. The Z should do the other axis, and the Y, it's not really that useful, but you can see it kind of pushing everything along that curve so that these ones are more spaced out and these ones are more compressed. And the scale out will be the same, but just for the tail of the bone. Now with this ease in setting, if you imagine an invisible Bezier handle coming off the end of the bone here, this value is the length of that handle. The larger the value, the more influence that the handle is going to have, and the smaller influence it's going to have. And the ease out value is exactly the same thing, but it's the handle on the tail of the bone. Okay, so now I've explained what nearly all of these settings do, and it is important for you to have an understanding of what these values are and where they are and what they do. But in reality, we don't have to mess with these things all that often. You can add drivers to things when you want to get super fancy and do specific stuff, but most of the time, we don't need to touch them at all because we can automate all of this stuff with the handle settings below. So let's jump in and have a look at that now. All right, let's look at the different handle modes. This is a little bit busy, so I will clean up the view in just a moment. I have 4 different setups here that show the 4 different handle modes. And the bone that we're affecting in all of these ones is the middle bone here. But our 4 modes are automatic, absolute, relative, and tangent. And just before we look at each one of these modes, I'll switch over to octahedral so you can see the slight difference with some of these setups. The first is a connected chain of bones, and this will be our automatic version. The second setup is all the same, except that there's no parenting involved. These are not parented to each other. The relative mode is clearly not connected, and I'd advise against doing what I'm doing here. And tangent shows that these bones are aligned with the main bone. They're all in the same direction. This is key with this option, as you'll learn in a moment. But first, our automatic version. This is the default setting. You don't need to do anything special for this setup. All you need to do is have a bendy bone, and if it's a connected parent, this is going to be the default behavior. If you rotate the handle at the end, it bends, and if you rotate the main bone, it's going to bend as well. Pretty intuitive stuff. Now with our scale XYZ for all of these bones, it's going to work the same, but we can enable this on our handles, and it's going to connect the scale of our handle to the scale of the main bone. I'll just do the X and the Z first. And when I scale the end handle here, you can see the effect that that's having on the bone. Pretty awesome. But with our scale Y, this is scaling along the Y axis of our bone. However, with this ease function, it's also going to connect that scale Y to the easing values up here. The next setup is the absolute mode. For this, you'll actually need to manually set it just by clicking in here and choosing the absolute mode. And then you also need to tell it what bone that you want to use as the handle. And that's because the bones can move away. They don't need to be parented with each other. And with this mode, it's very similar to the automatic, except for the direct parenting. However, it does get a little bit chaotic if the position of these handles does move away from the main bone. Next up is a relative mode. This one is super chaotic, and I would advise against using this altogether, but it is meant to work from the relative starting rest pose. But as you can see here, it's super finicky in many situations. It can just move a little bit too fast and jerky, and so there's better options for you to choose from. Next up is tangent. This one is fantastic. And this works exactly how you would expect, as long as the handles are aligned with the main bone. If they're not, you're going to get some bending in your edit bone, and that's probably not what you want. And that's all of our options. The automatic version will just use the connected parents. This is one that we use quite often because you don't need to do anything special. As long as the bones are parented, this is going to be the default behavior. There's no setup required. Absolute works okay under the right conditions, so I'm not a fan of using this one. The relative method is totally unusable. Stay away from this one altogether. Pretend it does not exist. But the tangent is my favorite. If you align the handles in the correct orientation in edit mode, then this option is the most flexible out of all of them. So that's all about B-bone handles. Believe it or not, there's more to learn about bones, so let's jump into the next lesson where we're going to look at these bone collections.